We think the Earth is about 4.5 billion years old, and that life evolved on the planet roughly 4 billion years ago. This is such a massive, incomprehensible amount of time that I like to think about the history of the planet from when it was formed until now, in terms of a single minute. On this scale, the dinosaurs were around 3 seconds ago, and humans evolved 3/100ths of a second before the present. In the history of the Earth, we've been around about that long. So what happened in the other 57 seconds? About half a second after the Earth formed, the Moon formed. Then the Earth passed through a rough patch known as the Late Heavy Bombardment, and at about 7.5 seconds into this 1 minute history, life started. This life was single-celled and microscopic. Microbial biology was the only game in town for the next 32.5 seconds, more than half the history of the planet. It's important to appreciate that the Earth, where life developed, was a very different place to what it is now. There was essentially no oxygen in the atmosphere, although there was still nitrogen, carbon dioxide, and inert gases. Life critically requires energy to impose order and rearrange chemicals into useful molecules. Nascent life had to work out how to use anaerobic chemical reactions as rather poor energy sources. By physically compartmentalizing molecules, microbes were able to use chemical reactions to move protons. They developed membranes as a barrier to keep protons out of cells. Then, by letting the protons into cells through an ATP synthase, they were able to harness proton motive force to do work, like a turbine driven by water pressure generated by a dam. Amazingly, at 14 seconds into the history of the planet, and only 500 million years after they first appeared, microbes worked out how to harness the energy from sunlight by inventing photosynthesis. Photosynthesis also pumps protons to drive ATP synthase. The ready availability of limitless energy provided an opportunity for biology to make some technological advances, such as the splitting of water. Halfway through this 1 minute history, biologically generated oxygen appeared in the Earth's atmosphere. The Great Oxygenation Event, or Great Oxygenation Catastrophe from the point of view of life that was thriving in its absence, provided opportunities for biology to evolve ways to harness more energetic chemistry, driving the development of multicellular life, which started to appear after about 40 seconds. The ferocious reactivity of molecular oxygen provided much higher energy levels for biological reactions, but also proved extremely toxic to many microbes. This selective pressure meant that microbes had to adapt or die. Many of them developed metabolic pathways to use oxygen and deal with dangerous reactive oxygen molecules. Others, now the strict anaerobes, found environmental niches on the planet away from oxygen, where they could continue to thrive.